What about Ibrahim and Tasneem?
Yes, ma'am. Yes, ma'am.
So in the last class, we started with the capacitance and basics of capacitance. We have done one additional thing that we discussed was the gravitational field energy. Okay, that was half into 1 by 4 pi g into g squared. Now, regarding spherical capacitors, I didn't mention it in the last class. Usually the formula of a single spherical capacitor, we have already done it in the class. Spherical capacitor. That is C is equal to 4 pi epsilon naught R. And this is for air. And if the material is something else, let's say there's a different medium. So we'll say C dash will be 4 pi K times epsilon naught R. But what if you have a concentric circle, okay, with charge same on it? Let's say you have okay, these are the two concentric spheres, spherical capacitors basically. So let's say this has the radius A, smaller one, and bigger one has the radius. This bigger one has the radius B. Okay, these are the radii of the spherical capacitor. So look, when you are calculating the change in potential, we have to take their magnitude first. Second, it will be E dot dr's integral from the formula of inverse of the relationship between the potential gradient. E is equal to minus dv over dr. So dv will be E dot dr integrated. So when you have such questions, if the radius is given, you can usually put the value kq by r square for electric field. dr will remain and you can integrate it for the radius from a to b, whatever it's given. So once you will integrate it, eventually your answer will be kq 1 by a minus 1 by b. So this is it. And one more thing here you should know, if let's say the charge here is plus q on this sphere. So because of the process of induction, the charge here will become minus q because we are talking about potential. So this minus sign can play a significant role. Okay. So that's why we have this. Now see, your delta V is nothing. It's just the change in the voltage, right? I'll just mention it here. This is the voltage. Is this clear till here?
Yes, ma'am.
Okay, one
Yes,
more
ma'am.
form we can have from here, which we have, I think, discussed in the class. When you're talking about the potential, you get Q divided by 4 pi epsilon naught. Okay, then B minus A by AB if you take their LCM. So see, when you have to calculate the charge, this is for the charge. Like here till here, you can get the formula for potential, that's enough. But what if you require the formula of the charge? Okay, so from here you can get the value of electric charge. Value of electric charge Q as, look, this potential will be multiplied to this whole term, which is 4 pi epsilon naught A into B divided by B minus A, the whole thing into the potential. So once the charge question has come, till now potential hasn't come in the NEET's paper, but in JEE this KQ 1 minus A minus 1 minus B has been used, 1 by A minus 1 by B. Okay, as one formula we've already studied for capacitance, that is this one, 4 pi epsilon naught AB divided by B minus A, which we discussed in the class. So this formula is going to come as it is. Okay, now one more thing, if you have the material change, this is for air. Remember here in this chapter, material plays a very important role. If let's say there is some different material, so here this will be 4 pi epsilon r into epsilon naught. You're going to multiply the relative permittivity over here. Okay, so epsilon r multiplied to the epsilon naught. Then you will have the rest AB divided by B minus A, which you can straight away say it is epsilon R into the capacitance of here, the capacitance of the new medium. Yes, tell me. Is it clear till here? Yes, Jobita, Ibrahim, Isleen.
Yes, ma'am.
Why are you all not responsive? Please open the cameras then. Write this, write All right. Class 1 formula we have discussed, and it has come multiple times in the NEET paper 2011, 2021, 2015's paper, and in fact, the papers before that. So, quickly in the chat box, all of you in the chat box, tell me what's the answer for this. This question has last came in your 2021's paper, and after that, it has repeatedly been coming. So just type the answer in the chat box. Yes, class. I think this is just a formula-based question. You just have to mark out the answer. Energy stored in the plates. Okay, Jesleen has the answer. Screen is loading. Just wait. Is it loading now? Can you see? Is it visible, class?
Yes, ma'am.
Okay, then tell me the answer in the chat box. It's not visible. What about Ibrahim and Rabata? You are not able to see it?
I can see. I can see.
Jesleen, rejoin. Yes, so those who can see what is the answer according to you, please type it in the chat box. This is a very easy question. I thought the answer would be just in seconds. Jobit Ibrahim, at least answer. Yes, Ibrahim is right. Correct. See, this says that a parallel plate capacitor has a uniform electric field E in the space between the plates. If the distance between the plates is D and the area of each plate is A, you just have a parallel plate capacitor with a distance D and the plate area is A. So it says energy stored. We have already studied about energy density. That is half epsilon naught E square. What is energy density? It's energy divided by the volume, half epsilon naught E square. So the volume of the plate will be nothing but A into D. That is half epsilon naught E square. So the energy will be half epsilon naught E square A into D. This is the whole form. So yes, this is correct answer is C. Please quickly write it. Such kind of questions, do not waste your time in it. These are just formula-based questions. Difficulty is that many students tend to mark the A option because by seeing the term energy stored, because this is the formula that is studied. But here only energy is asked. When energy density would have been asked, then this would have been the answer. But this isn't because energy stored in the capacitor is asked. Write it quickly. One more question we'll do. Justine, is the screen visible now to you?
Yes, ma'am.
Quickly write it, then let's move to one more question. Yes, class. Done? Or still writing?
Yes, ma'am. Done.
Ma'am. Still writing.
Justine writing? Completed.
Yes, ma'am. Done, ma'am.
Okay, class. So this is the second question. So it's from 2020's paper. Look, this says the capacitance of a parallel plate capacitor with air as the medium is 6 microfarad. So capacitance is air is what? 6 microfarad. With the introduction of a dielectric medium, capacitance becomes 30 microfarad. Okay, so let's say this is C dash. This becomes 30 microfarad. It is asking us the permittivity of the medium. What is the value of the permittivity of that medium? Means what's the value of epsilon? It's a very good question. Yes. Can anyone tell me what should I begin with, or how should I begin this question? Anything you will suggest? What should be the first step? What should I get? Okay, tell this if I take the ratio C in air divided by C in the dielectric medium. What will be this equal to? Can anyone answer this? C in air by C in a medium. Yeah?
Mom,
Ma'am, is
C
it
of air or C of the medium will be what? Epsilon into C of air. Yeah. C of the
Yeah.
medium.
Epsilon into C of the medium. That is right. But I already have this, right? This is already present. You're saying this is epsilon. That is not epsilon. Epsilon won't be given. That is something else which you're missing, Ibrahim.
Oh.
Just closer. You're very close. Okay, think it of like if I write, forget 6 and 30. Think I'm putting in the values. C is epsilon not A by D. Some dielectric medium is there. So that when I take their ratio, what will be left? What do you think? Try to put in through the formula and think which quantity will be left. C is epsilon not A by D.
Yeah,
C
C is
dash,
epsilon of the
yeah, C dash should be,
epsilon of the medium epsilon dash A by D.
no, you're forgetting something, Ibrahim. See, that epsilon of the medium, no, is written as K times epsilon naught.
K, yeah.
Yes,
Okay.
K. See, how can epsilon come?
The med-
This epsilon will come. That's the question, right? That's what we don't know. That's what we have to find out. If I get this K and then I multiply it with epsilon naught, that's what we've been putting. See, C in air is nothing but epsilon naught A by D. C in a medium, let's say some C dash will be K times epsilon naught A by D, then only I'll be able to take the ratio. If epsilon is given, how will I take the ratio? If you take the ratio, you'll ultimately have to put in the value of K. So K, we don't know. So for that, if we take the ratio, we'll be just left with K. So K will be equal to, oh no, I've written it opposite, C dash by C here. This will be C dash by C here. So this will be equal to K. So C dash will be 30 microfarad by 6 microfarad, which is 5. So the value of this dielectric constant which was missing in the question is 5. We get K as 5. Now you have anything. K will get you the value of this permittivity. Epsilon is K times epsilon naught. K is 5. 5 into 8.85 into 10 to the power minus 12, which is 40. So 0.44. So B option. B or D? 2 points. So yeah, B option. Yes,
Mom
B.
into 10. Okay, B.
Into 10 to the power minus 10 is here, and here it is 12. So it will become 0.44 into 10 to the power minus 10. So this is the answer. Write it and let's discuss the formula of the cylindrical capacitor. We haven't discussed it in the class. That's because it's just exclusively for your entrances. That doesn't come in the exam. Please write this class. This was a good question from 2020's paper. Have you seen this year's paper, all of you? We'll do questions from that. The dielectric slab part came from this chapter. The dielectric slab came. The one which we have done at the end of the chapter, if you remember, series and parallel of the dielectric slabs. From there, the questions came. But it was lengthy. Okay, write it. Done? Just let me know once done.
No, ma'am.
Done? Others? All right, so let's move to the cylindrical capacitors. Cylindrical capacitors. So see, the formula of the cylindrical capacitor, you basically will be considering the lambda, linear charge density, because see, it's like you have entrapped a wire in the Gauss law. So similarly here also you will be integrating the lambda. So see, what you can integrate is 2k lambda divided by r into dr from the radius, let's say a to some b. This means these are concentric cylinders like this. This and one cylinder inside it, like this. So one of them has the radius A, second has the radius B, like this. You have. And length is, let's say, L, whereas the linear charge density will be lambda. So you can just simply integrate it. When you integrate this, you can write the value of lambda as Q divided by the length. And of course, K, you can write it as 4 pi epsilon. Okay, 4 pi epsilon. Now, see, you will be left with integral of dr by r from A to B. Can anyone tell from the knowledge of integration, though we have discussed those students who were there in 11th, what is this?
Ma'am, log mod r. Log
Yes,
mod r
very
to
good.
the limits v2.
Whenever you have class, integral of dx over x, or this is written as 1 by x dx, like this. Both of them, you will write it as log of x. Okay. So here, when we write the formula of the potential, this will be 2q divided by the length divided by 4 pi epsilon naught log of v by a. Okay. And see here, if you just want to find out the value of the charge, though calculation of the charge till now has not come in the exam, 2 pi epsilon naught, see 2 will get cancelled, so 2 pi epsilon naught length divided by log of v by a, this whole thing multiplied to the potential. So this way it gives you the value of capacitance, Q is equal to CV. When we take the ratio, we'll get the value of capacitance as 2 pi epsilon naught L divided by log of B by A. This is the formula of capacitance, and that's the whole derivation. You can write down these derivation and remember them because sometimes they are helpful within the question. That's why for here also I made you write this, how you have to start with the derivation. For the cylindrical capacitor too, this is how we start with it. We just write the potential. This is the electric field. If you remember, we derived it in the Gauss law when the wire was trapped. So the same thing, we have just extended it. It's just that log will come here because it is integral of dr over r. So log b by a, this is the potential. From here we get the value of the charge. When we rearrange the term, capacitance is being given by 2 pi epsilon naught log b by a. That's it. Is this clear? Is this formula clear?
Yes, ma'am.
Okay. Write it. Then let's see the plates. We have done the combination of plates in the potential part. In the electric field, we have done. Let's see for the potential. 3 plates we do. We have just done 2 plates, combination of 2 plates. Now we'll see 3 plates. So method is the same, but first Done.
Done, ma'am.
Okay. Coming to the parallel plate capacitors. Parallel plate capacitors are left and the combination of capacitors. So parallel plate capacitors. Let us first discuss the formula that we have already done it in the class. So class, tell me, if you have two capacitor plates with air completely filled with them, what will be the formula of capacitance? Jobita, you tell me this. What's the formula of capacitance? We've discussed this in today's class also. Assume area is A, separation between the plates is D. What will be the capacitance in air? You must have written it also. Yes, Jobita. No idea. We've done it multiple times. C is equal to epsilon naught A by D. This formula has to be remembered by you, Jovita. This is not very important for your NEET. It's extremely important for your boards exam also, if you don't know this formula, because with the help of this formula only, you will be able to derive other formula that are there. So remember, if you're forgetting, just revise it once. And second is the same thing, but it is filled by a material K. Anyone who can tell me this? Filled with K. Capacitance will be, we've discussed this also in today's class itself. It is completely filled with a dielectric slab of
Ma'am,
K
E naught K A by D. K E naught A by D.
K E epsilon naught A by D. Yes, K epsilon naught A by D. Okay, if there is a partially filled dielectric slab, who remembers this formula? This also we have done it in the class. Anyone? Any idea? Do you remember this? Partially filled, two things we did. One was electric field, one was the dielectric slab. Epsilon naught A by T minus T plus T by K. This is the formula. Please don't forget this. These are very important for your CBSE's board exam. Forget NTA's NEET. First have the CBSE's board exam grip. If there's a strong grip, then you'll be able to manage with the rest of the questions. And if there is electric, I mean the conductor has been put here, so electric fields within the conductor become zero, so capacitance is epsilon naught A by D minus T. These four formulas should be remembered by all of you, even if you're forgetting right now. Ibrahim, Jovita, Jasleen. These, without these formula, parallel plate capacitors will not be able to solve anything, whether it's your regular class or it's your NEET class. In NEET, many questions have come from this, especially the dielectric slab. This year's paper, if you pick, there was a question similar to which came in 2016 once. An exact question came like your 2016 paper. So that was based on the electric slab only. It's just that the question was very lengthy. Many students couldn't complete it on time. Okay, so this is question 3. Let's discuss this. See, this says a parallel plate capacitor having cross-sectional area A and separation D has air between the plates. It means initially it has air between the plates. So cross-section area is A, separation is D. So epsilon naught A by D is the formula. Second, it says, now this figure happens, means an insulating slab of same area of thickness D by 2. area is same, so we'll take A, but thickness is d by 2. That is, T is given as d by 2 with a dielectric constant K is equal to 4. And you have to find out the ratio of both the capacitance. This is which case? Which formula will be applied out of all these? Let's say this is 1, 2, 3, and 4. For the second one, first I have told, in the first case, air one is there, this one. For this case, out of all the 4 formula, which one should be applied? At least formula usage you should know. Yeah, Jasleen.
Dielectric.
Yes, Jasleen, you're answering? You are not audible, Jasleen. Please type. Dielectric one. Dielectric one, which one? First, second, third, or fourth? I've marked the numbers. Just tell me, pick the number. Second, no. This is completely filled. Look, directly the figure is also given in this. It is partially filled, class. Look, this is partially filled. How can you see this is completely filled? This is partially filled case. Yes, the third one. So C, let's say this is C dash. This is epsilon naught A by D minus T plus T by K, where all the details about this is present. Okay, no problem, Jasleen. It's just that this is the partial one. When it was completely filled, then that formula would have been correct. So here C dash would be epsilon naught A by D minus T is D by 2 plus T by K. T is D by 2, K is 4. This is what we are getting. Epsilon naught A by D minus D by 2 plus D by 8. So I guess we should take the LCM as 8 and answer should come B option because 8 will come in that only, but let's check. T dash, if we take 8 LCM, this will be epsilon naught A by 8D minus 4D plus D divided by 8. 8 goes up here. So look, what's T dash coming? T dash will come 8 times epsilon naught A by 8D minus, yeah, that will come out to be is to 5 only. Look, this is 5D. And C air is epsilon naught A by D. So we have to take the ratio of original, new to original, means C dash by C air. This is what we have to take. C dash is 8 times epsilon naught A by 5D. C air is D by epsilon naught A. This gets cancelled. This is equal to C dash by C air is equal to 8 by 5. Ratio is 8 is to 5. B option. Tell me, class, did you understand this question? This was from your 2020's paper. COVID time. Clear?
Yes. Yes.
Write it. And if there's anything you want to ask, in this you don't have anything different. A new formula isn't there. These 4 are there, which on the basis of which questions have come. I'll give you it in the homework also. Formula part, yes, you're right. You write the formula also so that in your notes it will be completed. Write this also.
Ma'am, can you scroll up? Done, ma'am.